Good morning to all. A very warm welcome from Rohini College of Engineering and Technology. I am G. Tankam, Assistant Professor, Department of Physics from Rohini College of Engineering and Technology. I am handling the subject Physics for Information Science with the subject code PH8252. In this video lecture, I am going to discuss about the variation of Fermi level with the temperature for N-type semiconductor. Course outcome: after successful completion of this topic, the students will be able to explain the variation of Fermi level with the temperature for N-type semiconductor. So to study about this, first you should know the formula for Fermi energy for N-type semiconductor. By using some derivation, we can find the value of EF. Now I have written only the value. So the Fermi level is denoted by the symbol EF, and it is given by the formula EC plus ED by 2 plus KT by 2 log ND divided by 2 into 2 pi ME star KT by H squared the whole power 3 by 2. In this expression, EC represents the lowest level of conduction band, ED represents the donor level, and K is the Boltzmann constant, and T is the temperature. ND is the number of donors. So how many donors we are adding with the pure semiconductor, that will create N-type semiconductor. Then Me star is the effective mass of an electron. H is the Planck's constant in this expression. Now in this expression we have T term, that means the Fermi level depends upon the temperature. So how does it vary with respect to temperature, that we are going to see. So the first case is at T is equal to 0 Kelvin, what will you get for the value of EF? So you see this previous expression, when you are putting or when you are substituting T value is equal to 0, what will happen? After plus we have some term, that second term, that will be cancelled because T is equal to 0. So you will get EF is equal to EC plus ED by 2. So at T is equal to 0 Kelvin, the value of Fermi energy or Fermi level is equal to EC plus ED by 2. So that is shown in this diagram. We have EF and conduction band lowest level, that is in this diagram, the lowest level of conduction band is EC, and we have a donor level ED. Now this EF value is lying between this conduction band and the donor level. So it is by 2 means it is a half of the value. So we are saying the Fermi level lies halfway between the donor ED level and the conduction band. Next, when the temperature is increased, what will happen? So when you are increasing the temperature from 0 Kelvin to high temperature, what will happen to this Fermi level? Here if you see one curve is there. The Fermi level is initially at T is equal to 0 Kelvin. It is shown in this diagram. From this T is equal to 0 Kelvin, the Fermi level is shifted downward, or it is shifting downward, or it shifts towards the valence band. So it is coming from T is equal to 0 Kelvin to, it is moving like a curve, and it is moving or it shifts towards the valence band. Why it happen like this? So when the temperature is increased, this extrinsic semiconductor will behave like a intrinsic semiconductor. Why? Why it so happen? Because when the temperature is increased, the number of electrons moving from the valence band from the conduction band exceeds the number of electrons moving from the donor level to conduction band. So normally for N-type semiconductor, the electrons will move from donor level to conduction band. That is the general process. So the electrons are moving from the donor level to conduction band for N-type semiconductor. But when the temperature increased, more number of electrons will be moving from the valence band, that is in the lowest level, valence band to conduction band. If the electrons are moving from the valence band to conduction band, these semiconductor will be acting as a intrinsic semiconductor. So the extrinsic behavior is changed into intrinsic behavior. So that's all about the variation of Fermi level with respect to temperature for n-type semiconductor. Thank you.